right, today's our last section in chapter 5, and it's on inequalities in triangles. So, using the triangle below and the measurements given, there is a typo. This is not 750 degrees. This should be 75 degrees. Otherwise, it would make sense. Tell us that the measure of angle 1 is 140, the measure of angle 2 is 65, and the measure of angle 3 is 75 degrees. What do you notice about the relationship between 1 and the measures of 2 plus 3? Parker? They add up to be equal. So 140 is equal to 65 plus 75. Does anyone remember what that theorem was called that told us that? The triangle exterior angle theorem. Okay, it's actually right here, triangle exterior angle theorem. We're going to learn a corollary, which is like an additional piece from that statement, something else we can include. Okay, so the corollary says that the measure of an exterior angle is always going to be greater than the measure of each of its interior angles. Okay, so the exterior angle, this will be bigger than this one and bigger than that one, basically. So the original theorem says that the measure of angle 1 would equal the measure of angle 2 plus 3. The corollary tells us that the measure of angle 1 has to be greater than the measure of angle 3. And the measure of angle 1 has to be greater than the measure of angle 2. That exterior angle is always going to be the biggest one, okay, because it's the sum of the two of them interior. All right, and then an extension from that is our theorem 5-10, which has no name, remain nameless.
Can you name it?
Sure, Dax, what do you want to name it? We'll wait till you see what it says, and then see if you can come up with it. All right, it says if a triangle is scalene, which we know that means it has three different side lengths, the largest angle will lie opposite of the largest side. And the smallest angle will lie opposite of the smallest side. Kind of common sense, but the common sense theorem.
Yeah.
So you'll be asked to list angles from least to greatest or greatest to least. Just make sure you don't read the directions wrong. They want us to list our angles from smallest to largest. So usually I go around and I label small, medium, and large. Smallest, the medium side, and the largest side. And then the angles have to be across from them. So since this is the smallest side, the angle that is not included, it's the opposite one, is going to be the smallest angle. So this would be the smallest angle, angle Z. The medium side was 29, so the angle that is across from it, cannot be the angle that touches it. Okay, it's always the one that's across from it, would be the medium angle, which would be angle Y. And then lastly, the largest side is 32. Its corresponding angle would be angle X, so ZYX. Theorem 511 would also be kind of like the converse almost of the common sense theorem. And it says that the largest side will lie opposite the largest angle. And the smallest side will lie opposite the smallest angle. So kind of going in reverse, if you know the angles, you can also classify the sides as being smallest and largest. Okay, now in this one, we say a 30 degree, a 90 degree. We don't know what angle R is, but we can find it. What would it be?
60.
60 using triangle sum. And then we can clearly see that the smallest angle is 30. So the smallest side would be the side that's across from the 30 degree angle, which would be segment SR or segment RS. Should have a segment bar. And then the next largest angle would be 60 degrees, so across from it would be QS. And lastly, the largest side would be the hypotenuse, which would be segment QR. See if you guys can complete example 3. Which side is the shortest? Which side would be the shortest? right, who can tell me what they got? What is the shortest side? Evelyn? Segment TV. So we should have used triangle sum to find that the other angle up here was how many degrees? 60. And then looking for the shortest side, you're going to look for the smallest angle and then go across from it. Okay, and again, that's because an angle defines how big or small the opposite side is. When you make it a bigger angle, the side would have to be bigger so that it touches. All right, on the back we have our triangle inequality theorem. I used to do an discovery, we're skipping that. All right, so this one just goes straight to the theorem, and this says that the sum of the lengths of any two sides, remember sum means addition, of any two sides, any combination of two sides, has to be greater than the third side. Okay, so if you want to know if a triangle can actually be formed by three segments that were a certain length, it would have to satisfy this triangle inequality theorem. So you basically have to test to make sure that when you add any combination of two sides, it's always greater than the third. So can a triangle have sides with the given lengths? If we were to have a 3-foot, I don't know, piece of wood, a 7-foot piece of wood, and an 8-foot piece of wood, is there any way that we can put them together that would make a closed shape? Because sometimes one of the sides is too big that it wouldn't actually close, it would be like an open figure. Okay? So to test this, we're going to test that the sum of any two sides is greater than the third. So we'll start off with 3 plus 7. Is that greater than 8? Yes. You have to test all three though. So next we could do 7 plus 8. Is that greater than 3? Yes. And then the last one I'm missing is 3 plus 8. Is that greater than 7? Yes. So yes, these would form a triangle, a closed shape.
Is this like for real? It seems like it's so much easier than actually being,
That's it.
it's like common sense.
Now, if one of them fails, the answer is no. It would not be able to close to be a formed triangle. It would be like an open polygon. It wouldn't be a polygon at all. It would be an open figure. So the explanation would just be it satisfies the triangle inequality theorem. Or you could say the sum of any two sides is always greater than the third. You can write out what the theorem says if you were explaining. Okay, now the next one. Started with our first two, 3 plus 6. It's greater than 10. You can stop right there. You don't have to test the other two. Okay, the answer is going to be no. It doesn't satisfy the triangle inequality theorem. So if you were to put those together, no matter how you bent the sides, they would never close to make a triangle. And sometimes they'll throw in word problems like Susie started in the park and she went 3 yards north and she turned and she went 4 yards east and she came back and traveled 3 yards back to her original starting point. Like, would she get back to her original starting point? Which is basically saying, would it create a triangle? Which would be this type of problem. So sometimes they can make it a word problem, which just adds in a little bit more challenging element, but not really. All right, the last two problems are going to be a little bit algebraic. They want us to describe the lengths possible for the third side if you know 2. Okay, because it can actually be a number of different lengths that would form a closed shape. When we are describing them, we're usually going to use an inequality. Actually, I'll say we're going to use a compound inequality. Okay, because the values are going to fall between two numbers, like be greater or less than a certain number, a range of values. All right, so we know that the triangle has an 8 centimeter side, a 10 centimeter side, and we're trying to come up with the lengths for the third side. So what I would suggest doing is define a variable. Let x equal the length of the third side. So our final answer is going to be some sort of compound inequality using x and numbers. we're basically going to do what we did in the top problem. We're going to test all three combinations. We now have 8, 10, and x. So we're going to do all three, adding two sides, making it greater than the third. So we would have 8 plus 10 is greater than x. We would have 8 plus x is greater than 10. And we would have 10 plus x is greater than 8. The order in which you write these, it doesn't matter. Like, you could do the other one first. You just want to make sure that you basically have different numbers on the other side of the greater than symbol. And you're going to solve each of these for x. Okay, so 8 plus 10 is 18. 18 is greater than x. Usually when you read an inequality, though, that variable likes to go on the left-hand side, so we would want to flip this one to make it x is less than 18, so that it makes sense when you read it. X is smaller than 18. So the value, or the length of the third side has to be smaller than 18. But it also has to be bigger than something, so let's test those. We'd use inverse operations here, subtract 8, to get that x has to be greater than 2. And also subtracting 10 here, we would get x is greater than negative 2. Okay, now we will throw out the negative one, but there's a reason why. So if you think about graphing all of these on a number line, okay, we want all of these things to happen at the same time, like an and compound inequality, so be where they overlap. So if I were to graph x is less than 18, and if I were to graph x is greater than 2, and if I were to graph x is greater than negative 2. Okay, you would be picking the portion of the graph where all three colors touch, where red, green, and yellow all touch, which happened between here. Okay, so the negative 2 kind of, I mean, you can just always throw it out because you can't have a negative side length, but that's why it gets thrown out too, because it also can't be 1 or 0 because it wouldn't satisfy all three of the compound inequalities. And then your last step is to write a compound inequality. Okay, this is an and compound inequality, so it's going to be that string of inequalities. You're going to take these two things and put them together. Okay, some students like to flip this one to make it 2 is less than x and x is less than 18. That's how the final answer will read. 2 is less than x, which is less than 18. So the values anywhere between 2 and 18, non-inclusive, could be decimals, could be whole numbers, would form a triangle. Jax.
Why is it less than 18?
If it were 19, it wouldn't close. Like, it would be that 19 side, like the other two sides wouldn't be long enough to close the shape. Now, some of you will come up with like a mental way to do this. The biggest number is adding the two numbers together. The smallest number is subtracting the two numbers, and then won't try to work for it, which is fine. But for those of you not picking up on that, there is the algebraic way to solve it. See if you guys can complete number 6 while I'm passing out. I'm going to pass out your homework, and I'm going to pass out the optional study guide. It's not required. So if you want to write optional at the top of it, to remind yourself, you can do that. But I know some of you like to have it ahead of time just to get started. Tomorrow we'll do a partner challenge, and then you will have some time to study or work on the study guide. So who can tell me what their final compound inequality red. Put together. Okay?
Alright, so it's the X degree, or less than.
Less than 15. These should always be less than symbols, both of them. Because whenever we read this backwards, this is really x is greater than 9 and x is less than 15. When you put them together, they're always going to be less than symbols. They could be less than or equal to in algebra, but in these types of problems, you're not going to have an equal to bar at all. So the values can be anywhere between 9 and 15. They can't be 9 and 15, but they could be really close, like 9.01, and it would actually work. All right, the closure says triangle ABC has side lengths such that AB is 5, BC is 8, and AC is 12. List the angles from least to greatest. So you may want to sketch a picture when they don't provide one. There are a couple questions on the quiz like this where they, and it may even have algebra, like angle A is 2x plus 3 and angle B is whatever. You may want to sketch a picture just so that you can interpret what's going on. Who thinks they could list the angles in order from least to greatest based on those sides? Evelyn?
Angle C,
Good?
angle A,
Perfect. Smallest side, smallest angle. Next smallest side, next smallest angle, and largest. There you go. All right, the rest of the time is yours to work on the homework.